Hi folks, in this video we're going to look at putting certain fractions, decimals and percentages into size order. We're just going to go from smallest to biggest. If you wanted to put them from biggest to smallest, then obviously you could just reverse the order when you're finished. So we're going to put these fractions, decimals and percentages in size order from smallest to biggest. Now, first of all, we start by, there's a few different ways to do this. We could change everything into a decimal, or we could change everything into a fraction or a percentage, and then we could just examine them from there to see which is biggest and which is smallest. Now, what we should always do when we start with this is just have a little think first and try to analyze all of the numbers that we've got and try to really get an idea of the size of that number. We can kind of tell straight away if something is bigger or smaller than a half. So do that first, and it looks like all of these numbers, apart from a half itself at the start there, all of these numbers look to be less than a half, because a half, we could always recognize a half as being 0.5 and 50%. Well, 1/3, we can think of that as splitting a pizza up into 3 slices and eating one of them. That's less than half the pizza because there'd be 2 slices left and we've only eaten one. 0.4, that's smaller than 0.5, so that's less than a half. 35%, 35 smaller than 50, so that's less than a half as well. So that means that 1/2 itself, since all the rest are smaller than a half, that's going to be the biggest. So straight away we know that that's going to be at this end. Now let's look at a third, 0.4 and 35%. I think the best way would be to put everything as a decimal in this example, just because 35% is quite easy to change to a decimal, and a third is one of those numbers that we should know it as a decimal really as well. So a third as a decimal is 0.3 recurring. If you don't know that one, memorize that one now. 0.3 recurring. A third is 0.3 recurring. That means 0.333333, and there's infinity threes. The threes just go on forever. They never ever ever stop. So a third is 0.3 recurring, 0.4 as the decimal is, you'll never guess, 0.4, and 35% as a decimal is 0.35. Alright, so all of these are decimals now, so we can put them into size order more easily. Well, the smallest one, 0.3 recurring, is smaller than 0.35 because that's 0.33, 0.35. This is like 33 is smaller than 35, or 333 is smaller than 350, or 3333 is smaller than 3500. So 0.3 recurring is the next smallest, is the very smallest. It is smaller than everything else. So let's put that at this end, 0.3. In fact, let's write it as it was, a third. So a third is at this end, a half is at this end. Everything else is between a third and a half, which isn't a very big gap. Alright, and then 0.35, 0.4. Well, 0.4 is bigger than 0.35 because 40 is bigger than 30 and 400 is bigger than 300. So let's put 0.35 there. Or actually, it was 35%, so this would be a good time to change it back to 35%. Let's put a comma. 35%. And then the last one is 0.4, so let's put 0.4. And that is our list. That's all the numbers in size order. Alright, let's have another go. We've got another example. So let's have a go at putting these numbers into size order. These ones are a little bit trickier, but first let's analyse to see how they compare to a half. So 5/7, 1/2, if we were to, well, let's look at how many sevenths it would take to make this one whole. If we've got 5/7, 2 more sevenths would make it 7/7. So it's past halfway, because half of 7 would be 3.5, 3.5. So this is bigger than a half. 3/4 is more than a half. 0.6 is more than a half. 50% is a half, and 5/11 is less than a half. So these three are more than a half. This is a half, and 5 is less than half of 11. So that means that 5/11 straight away we know is the smallest. Let's put that down there, 5/11. 50% is going to be next because that is a half, and all the rest are bigger than a half. And now we've only got 3 left to deal with, these 3. But that 5/7 looks a little bit intimidating. Alright, let's compare 5/7 to 3/4. So 5/7, that's 2/7 away from 1 whole 1. 3/4 is 1/4 away from 1 whole 1. And if we double 1, we get 2. So if we double the digit in this, it might be a bit easier to compare. So just bear with me a minute and let's do that, and you'll see why I've done that once we make that comparison. So if we double the 3 and the 4, we get 6/8. Now think of how far away these are both from 1. This is 2/7 away from 1. That's 2/7 away from 1. This is 2/8 away from 1. Now if this is 2/7 away from 1 and this is 2/8 away from 1, we can figure out which is closer to 1, because we can look at which is smaller between 2/7 and 2/8. 2/7 is bigger than 2/8, because when you cut something up into 7 pieces, the pieces are bigger than when you cut them up into 8 pieces. So if this is 2/7 away from 1, it's a bigger distance away from 1 than this is. That means this is closer to 1. That means this is bigger because it's closer to 1. From 0 to 1, this is closer to 1. So if we've got 0 there, 1 there, 6/8 is really close to 1. 3/4 is close to 1. 5/7 is further away from 1. 5/7 is there. So that's 5/7. That's 6/8. So 6/8 is only 2/8 away from 1, whereas 5/7 is 2/7 away from 1, and 2/7 are bigger than 2/8. I know that might seem really confusing, but I think that's probably the easiest way to figure out what's bigger. In fact, it's not. One other little way, if that's really, really, really confusing, do this instead. Just change them both to be over 7 times 4. So 5 and 7, times them both by 4, we get 20/28. And 3/4, times them both by 7, we get 21/28. So 3/4 is bigger than 5/7. So you can do that instead. Alright, so now we know 3/4 is bigger than 5/8. If you understood this, then you knew it anyways. 3/4, 5/7, sorry. 3/4, 5/7. So now we know 3/4 is bigger than 5/7. So we can write those in. And also we need to think of 0.6 and how that compares as well. Alright, well, 0.6 we could think of as 6/10. So what we've got so far is 5/7 and 3/4. Alright, 0.6 goes either there, there, or there. So let's figure that out. 0.6 is 3/5. If we were to convert that to a fraction, 3/5 is, we could think of this kind of like this, like what we had before, where they're all 2 somethings, 2/7 or 2/8 away from 1. 3/5 is 2/5 away from 1. Fifths are massive compared to 7s and 8s, so 2/5 away from 1, it's way over here, just past halfway. So 3/5, we know straight away from that, is going to be smaller than both 5/7 and 3/4. But if we wanted to, we could compare it to 5/7 by making them both have a common denominator. 7 times 5 is 35. So let's multiply the 5 and the 7 by 5. We get 25/35. And if we times 3/5, the 3 and the 5 by 7, we get 21/35. 21/35 is less 35ths than 25/35, so that means that 3/5 is smaller than 5/7. So that means that 0.6 is smaller than 5/7. So that means 0.6 goes here in our list, because it's bigger than a half but smaller than 5/7, which is smaller than 3/4. So our final list, our size order list of those numbers, will be 5/11s, 50%, 0.6, 5/7, 3/4. So there's a few different ways to approach some of that. That might have been a bit confusing, but just use whatever works best for you. And it really depends on the numbers in the list as well. Try to really analyze them. Try to just go through each number one at a time. Compare them to a half. You can compare them to other fractions like 3/4 and 1/4 as well, if that makes more sense. Sometimes you have things like 0.6 recurring and 0.67. You'll have like 0.67 or 0. Just 0.6 lists with things like that in them. I've seen those come up on GCSE tests before. So obviously in that case you would want to compare all of them to 2/3 because they all kind of look like 2/3. So just look at what's bigger than 2/3, what's smaller than 2/3, and then try to put some of them in order from there. So really try to analyze these sorts of lists when you get a question like this. And that's it. Thanks for watching, folks.